Thank you. I'm part of the engineering team at Pure. My assumption is that many of you may not be familiar with our company. So I want to give a little bit of background on who we are, the data analytics challenges we face, and how our experience with Spark fits into that context. We build all-flash storage arrays, a storage infrastructure that goes in data centers, either in a traditional on-premise facility or increasingly in private cloud deployments for leading SaaS providers. In the context of Spark, we provide a fast, big, and exceptionally simple storage platform that can replace racks of HDFS with just 4U while delivering more performance than most single applications can consume. You can get the flexibility of decoupled storage and compute, as you see with S3 and cloud-based deployments, with more performance than you get from most HDFS clusters. We've heard some amazing talks today at the summit about the incredible utility of fast access to large volumes of data and how that can lead to competitive advantages for all kinds of organizations. At Pure, we believe that agility is the third key ingredient for data-intensive applications. But what do we mean by agile data? When we say agile, we mean installation in under an hour. It means a getting started guide that's the size of a business card. It means non-disruptive upgrades. It means enough performance and scale to consolidate a data center worth of workloads. And very importantly, it means 6 nines of availability across our fleet of installed products, including upgrades and maintenance. Our customers clearly love the agility that we enable for them. One of the key drivers for this satisfaction is the proactive nature of our support. In most cases, we call our customer first to tell them about a potential problem and schedule preventative maintenance. A key aspect of that level of support is the predictive analytics that we perform based on telemetry that's phoned home from our products. To date, we've been able to automatically identify and resolve 7,700 potential incidents, and 177 issues are avoided because we're constantly analyzing audit logs and telemetry coming from our systems that are deployed in the field. The data we collect, always with customer permission, is massive, varied, and streaming at us in real time from a number of sources. Today, we face 2 critical challenges in our infrastructure. First, we have to deal with a large combination of content sources, schema versions, and analyses we want to perform. This has led to a multitude of tools, mostly created in-house as needed to store and process all the data. Second, our success as a business has created an infrastructure headache, a classic big data problem many of you have likely felt, where we now have over 5 petabytes of data across a number of silos, sprawling infrastructure that we have to manage. So I want to look at each of these 2 challenges in turn, starting with the variety of analysis tools that we're running. So let's look at the streaming telemetry specifically. You can think of this in a broader context as our sensor network. Every box that we ship with customer permission can then phone home its telemetry. We have thousands of deployed products in the field. We run a massive sensor network. So in addition to storing the raw log data that comes back into a big file system, we also push the logs through a custom pipeline that extracts key performance data and performs basic time series aggregation. These results are written into a database. We use Postgres today, where we can provide efficient access for a variety of subsequent tools. And for many kinds of analysis, this works very well. Like a classic database architecture, we achieve great results for questions we've anticipated ahead of time. But importantly, for ad hoc queries that we didn't anticipate ahead of time, this can be extremely slow or even impossible, especially if we wanted to look at an ensemble data across 1,000 deployed products over a month. The volume of data, the analysis over that is too difficult for us to do with our current suite of tools, efficiently at least. So in experimenting with Spark, we found that we can move the raw logs into an archival role. We can shift extraction, transformation, aggregation, and loading of data into a single tool chain. We can build libraries that are extensible for working with our logs as they evolve over time, and we can leverage the state-of-the-art formats and storage backends like Parquet, Elasticsearch, as well as traditional relational database engines, all from sort of the context of the Spark ecosystem. It's no surprise that we can now answer questions orders of magnitude faster than before, all with a more robust and concentrated set of tools that are more extensible to new use cases. One of the most exciting parts about the Spark ecosystem is the chance to unify our ingest pipeline with a stream analytics workflow, all with a single code base and reusable components. We can still do the core ETL and aggregation operations, but also integrate our real-time alert processing into the same suite of tools. Thus, the set of capabilities in Spark makes it a great candidate for consolidating our disparate workflows. Why am I saying candidate? Well, in many ways, Spark is still very young, and there are some rough edges. In our experiments, we found a need for improving the streaming ingest performance of Parquet and the storage backend, is particularly the visibility and how we tune that. It takes a while to get that right and really get the system behaving the way we expect. We'd love to see more indexing options that allow us to do point queries. There have been some of those, the genomics talks that we've seen today have highlighted some areas where that's growing. We'd basically like to take the set of things we outsource to complementary tools in the ecosystem and pull those more and more into Spark where it has more of a consolidated feel. And it isn't that hard to get the system to on us. I think a lot of folks that have really used Spark at scale have experienced this. It's getting pretty good, but there is still enough tuning knobs where getting that right can be a challenge. Once we get the tuning right, it seems very stable, so we're quite happy with that. So in general, Spark is, looks like a great platform for us to consolidate a lot of our tools and workflows. The community is there. There's clearly a lot of momentum, and we're excited and happy to be a part of that. So I want to look at the second of the challenges that I talked about. Spark looks like a winner for the first of these, but what about the massive disparate silos of data that are showing up across our ecosystem? Well, let's identify the origins of these data and infrastructure silos. In many data pipelines, we're likely to find 3 to 4 more distinct data stores, each keeping a transformation of some original data set optimized for certain access patterns. I may have a large data lake sitting in HDFS. I may keep some rendered indexed view of that in Postgres for fast access. I've indexed some text-related portions or documents in Elasticsearch, and I've got my message queuing in Kafka, just as one example. Right? Each one of those is its own storage and compute infrastructure, and then we build applications on top of these things. Now, this is problematic, but this is really just one potential data pipeline. At a large organization, you're going to have hundreds or even thousands of these databases, these pipelines, these workloads that exist. So as you multiply each one of those pictures across the business groups and their own data silos, the footprint and operational complexity explode. Pure is still a fairly small company. We have about 2,000 employees. We have over 100 production databases. I know many large enterprises have thousands that they run. So this, for our customers, this is a real problem, especially as they look at some of the new breed of tools where they're composed by many piece parts that are specialized. The infrastructure explosion that exists is causing major pain. So you get racks of equipment that are installed, but they're often relatively low utilization. We've got the big system that's always on, that's sized for peak performance, but then we've got lots of others that are production. They're important that they stay online and available, but they're consuming compute and storage infrastructure just because of how it's built. So why is this happening? In many ways, it's happening because we're coupling storage in the form of hard drives or SSDs directly to servers running data-intensive applications. We cannot easily consolidate those applications onto the underutilized compute infrastructure because it's been dedicated to also be the corresponding storage platform. To improve utilization, reuse infrastructure, and consolidate data center footprint, we need a large capacity, high performance, effortlessly simple storage platform that is connected but fundamentally independent of our compute servers. We looked around for one, we couldn't find it, so we built one. And that product is called FLASHBLADE. So FLASHBLADE is an all-flash scale-out file system and object store. It scales to very large capacities, 550 terabytes to 1.6 petabytes or more, depending on data reduction, in just 4 rack units, so about yay high. It delivers tremendous throughput across a range of applications and access patterns, from large streaming operations at 15, 16 gigabytes per second to small file and metadata access at over 1 million IOPS. For what it can do, it's remarkably simple to deploy, manage, and use. There's no rebalancing, pools, no silos of performance. Let's look at an example in the context of Spark. So our studies with Spark have been done as part of a larger suite of analytics tools. We've been able to store all of the data from multiple formats, multiple applications, concurrently on one FlashBlade system. Now, FlashBlade, as I said, is a scale-out file system. It exposes NFS as its primary storage interface. So it's, despite being a very classic storage protocol, there sits behind that an extremely high-performance, high-capacity engine that's capable of consolidating racks of traditional storage infrastructure. And this screen capture on the right here shows from our GUI, it shows one real-world example where we were running a Spark query with a 1,000 core compute cluster. We're accessing a data set that's stored, it's formatted in Parquet, but hosted on a 250 terabyte FlashBlade. And so it's a little bit small, but you can see the read bandwidth. We were hitting about 8 gigabytes per second sustained reads for the duration of that query, right? We're feeding quite a lot of data very fast, and latency topping out at about 2.5 milliseconds per I/O. So at that kind of throughput, delivering that low, consistent latency, that's what we do. That's what we've been doing for several years in other application areas. And we see that kind of performance and performance consistency as much needed in the Spark ecosystem as we consolidate more and more applications and more storage platform applications onto a single piece of infrastructure. And so if you look at what, just in this one example, we were able to do, we can shrink 5 racks of typically HDFS type storage deployments down to 1. We get tremendous flexibility. We can scale compute and storage independently now. So if you've got a multi-petabyte data store, if you need more capacity, you're not buying big fat servers to go in that if you don't need the compute. But similarly, you can gain tremendous efficiency as we can now consolidate applications on the vital compute we've got. And one of the most exciting use cases is for the data science team, where we can now spin up multiple compute clusters, give a dedicated compute cluster for a data science group. They can go and access that high volume, that large capacity data and achieve tremendous performance, running side by side with a production application. So this is really just the beginning of FlashBlade and Spark. We have a very large, very fast, and for what it does, exceptionally simple storage platform. We found in our experiments so far Spark to be almost an ideal tool for building fast analysis across a range of use cases. It looks like a great great form for consolidating our workflows. And running Spark on FlashBlade is enabling us to consolidate infrastructure and give us a lot of flexibility and efficiency for our data science and the supporting teams. Thank you very much. If you've got other questions, we're happy to talk to you downstairs in the expo hall or offline in the hallway here. Thank you.